All right, so Christian's marble jar currently has 90 marbles. Each week he goes to the store and purchases 4 marbles to add to his collection. So I need to figure out which words describe the situation. All right, so I'm going to say that it's definitely linear because it increases by 4. Let me get my pen. It increases by 4 every week. So it increases, so it's increasing. Okay, since it's plus 4, I know that that's arithmetic and linear. Okay, and since it gets 4 every week and it's not necessarily like gradual, it's 4. This week is 4. This week is 4. That's also discrete. Okay, the second one, since we have a table, anytime that they just give me a table, and it's a sequence like this, it also has to be discrete. Okay, I'm going to look at this. It's plus 22, plus 22, plus 22. So it's increasing. Okay, and since it's plus 22, that's a common difference. So it is linear. Okay, let's look at number 3. When I start measuring the height of my plant, it was 2 inches tall. It's been growing at a ratio of 2.5 inches. Okay, so it's growing, so I know it's increasing. Okay, this ratio tells me that it is exponential. Okay, and I need to say continuous or discrete since I can calculate this at a random time, and this is an explicit function, then I know it's got to be continuous. Okay, we're going to open a savings account with her money. She had $20 when I opened the account, and each month she deposits 10. The situation described is modeled here. Okay, so again, she adds 10. Okay, so since she adds 10, that's increasing. Since it's plus, it is linear. And since it's a table and she just does 10 at the end of every month, at 2.5 months, she doesn't have 45 in there. So it's also discrete. Okay, Tom has $5,000 in his savings account. He spends 1/10 of his money every month. Okay, so he spends 1/10 of his money every month. We want to know how much is in a savings account. So this would be decreasing. Okay, since his money's going down. All right, he spends 1/10. I know anytime I go down by a ratio like this, or I have a percentage, this would be like 10%. Okay, I know that this is going to be exponential. Okay, so increasing, decreasing, exponential, and finally, since he spends his money like that every month, and this one I would say could be discrete or continuous. I'm going to say that this one is discrete. Okay, when flipped, an hourglass drops 224 granules of sand every minute. All right, so that's decreasing. It's losing sand. Okay, it is linear because it loses 224 every minute. Okay, and since that's at a constant rate, I know that it is continuous. Okay, because you can actually stop this and say how much is there at half a minute, and since it's at a constant rate, I can tell you it would be 112. Okay, which functions below do not have a common ratio? All right, so this means do not have a common ratio, so that means they would have a common difference. Okay, number 1, this looks like a linear equation. We have the y and x, and there's no exponent here, so I'm going to circle that. 3x plus 12. Again, that looks like slope-intercept to me, so I'm going to circle that. This one here, I have 1/3 x. If I distribute this, okay, I have 1/3 x plus 4. So again, it looks very linear. It doesn't have a common ratio. And finally, the last one, or this one here, is times 12. This looks like a recursive with multiplication. So I am not going to do this. Sorry, this one is a correct answer. And also this one down here, this is exponential as well. That's written explicitly. Okay, here, which of the following have a common ratio? So I'm going to try to find the ones. This one has a common ratio. It's recursive and it's multiplying by 5. And this one is exponential also. It has a common ratio because I have that x in the exponent. These are all linear. Okay. So now this says which do not have a constant rate of change. So this says which is not linear. Okay, so what is not linear? This is not linear. It has this as an exponent. This is not linear. It has a common ratio. And the rest of these are all linear. Okay, number 10, which function below have a constant rate of change? So this one again, which is linear. Okay, this is linear, x and y, no exponents here. Okay, this is linear. This one has this exponent, so this is not linear. This one has a plus 6 at the end, so it's recursive, but it is linear. And this also is linear. I'm going to circle that. All right, 11 through 12, let's match. So match the equation on the left with its constant rate of change on the right. So this constant rate of change, our constant rate of change can be found by my slope. So it should be -7. So the first one is C. Here my constant rate of change is going to be a starting point multiplied by 7 every time. So this one should be B. Here is a constant rate of change of +2. Nope. The constant rate of change of 7 should be B. And finally, this constant rate of change I'm going to need to solve. Okay, so it's going to be 7y equals -2x plus 15. And then I need to divide everything by 7. So y equals -2 over 7 plus 15 over 7. Okay, so my constant rate of change is -2/7, so that should be A. Okay, 15 through 17, the number of dogs adopted last 4 months was this. Okay, this looks to be increasing by 3. So that's going to be linear. The number of what's now a case decreasing by 1/2. Anytime it decreases by 1/2, I know it has to be exponential. The number of red cars in Palos Hills last month was 150. So this increases by 50. This increases by 100. So this actually is, if we divide these, we can do 150 divided by 100, which equals 3/2, which equals 1.5. So it's actually exponential.